over here, and we're just going to do a basic Python, Flask project. In fact, there's like 2 lines of code in the whole thing. We're going to press examples, server Flask, and this is it. So basically, when we press run, it's going to open up a web page, and it's going to take this string, hello world, and it's going to send it. In other words, Python is installing a web server. It's going to send it, and it's going to pass it out, or we'll see that open here. And it's going to say, hello world. Here is the URL, so you can look at it. And I'm going to put it in the chat, and just give it a click. So here's the link. Let's give it a click. You'll notice that as you click on the bottom, every time you go to AppRoute / the default main directory of the site, it's going to update. And everybody who's clicking right now on my screen, you'll see that it shows error code 200, which means it worked. And 404 means the favicon is missing, right? There's supposed to be a favicon included in the site. That's the little picture up here at the top. And I didn't include one because I just made this in 1 second. So it's saying it's missing. We're trying to send it. We don't know where it is. But if you go there and you press the button a bunch of times, you'll notice that Flask will be updating at the bottom as it sends it out, right? Now, we have this thing called a decorator. That's the @ sign. And we say, if you get traffic going to AppRoute /, in other words, if somebody goes to the main page of the website, there's nothing else there, then run this function, hello world, and print out that string. Return it. It returns it to the web, and you should see it showing up on your screen, just like I have. It will say hello world. We're on the same page? All right. So, I mean, that's exciting, but all we're getting back is a string. So what about other things? We could tell it to send back not just a string, but we could say a web page. So here's a web page that I made with Vin. And we said from Flask, import Flask, render template request, and then he imported send mail. Now, what this is at /, it says render template index.html. So we have in this folder templates, there's all these different elements. We designed a thing when we were working on this. And index.html is rendering this file. In other words, when you hit that /, it sends it out, right? So I'm going to press run. Sorry if this generates a million emails for Vin. Let's see. So we'll install that for a second. And it's running, right? So let's go. We'll open it in a new window. Here's the web page. You'll notice that now, instead of sending back a string, it sends an HTML page. It's responsive. It has this nice email box. I could write my email, press send. It's not connected right now, so it's not going to work, but you get the idea, right? Basically, instead of sending you back a string, it's sending you back a website, HTML files. We have a generic page. We have, without the CSS, we have a regular email page. There's social buttons up here, the whole deal, right? So in this case, when we go to the / here, it renders index.html. When you get to index.html and you fill out that form with your email, we basically say, if request method is post, then grab the this field called receiver, save it as data email address from the form, save it inside receiver, and then send mail receiver, send the person an email using the program down here. Make sense? So basically, to make a long story short, we're going into this folder called templates. It's using assets and images, which is the template inside of here. It customizes it, and when you hit the /, it sends you the website. And in this case, when we hit the /, it sends us, sorry, I turned it off. In this case, it sends us a pretty fancy website, nicer than a string, right? There's a picture, a typewriter, etc. Any questions, comments, or thoughts? We're good? All right. So, a regular question that people often ask is, what happens if there's no API? Or, how do I make an API? Or, I can't find an API that serves up pictures of whatever, or data. And this is a big problem because if you have a lot of developers that are building software just like you are, but they need an API to connect to, just like the programs that you're doing, how do you do that? So today we're going to learn about a package called FastAPI. And the reason why I showed you Flask first is because Flask is the exact opposite of FastAPI. Flask creates web pages. Today we're going to create an API. So an API doesn't necessarily serve up a web page, but it could. We're going to look at that later. But what it really does is it takes a data structure in Python and it sends it out to the web in JSON format. And you've already used this, I'm sure, before because you've gone to a lot of APIs. So let's start with an example at the very, very beginning, and I'll explain how it works. So we'll start over here. Let me just organize my code a little bit. Okay, so here is, sorry, I don't even know which window I'm sharing anymore. Here it is. Okay, so here's the code. We have from FastAPI, import FastAPI. That turns on FastAPI. And I'm going to send you out a million links and instructions along with everything you're seeing today. So you don't have to type everything in. It's really important to understand how it all works together. And I'll send you some of the code. Then we have import Uvicorn. And what that does is that's going to set up sessions so multiple people can go to the site at the same time. Just like we had in Flask a minute ago, we have app equals FastAPI. In other words, create an instance of app and turn it on. Now you'll notice something really familiar. It says at app.get / when you go to the / or the main directory of the site, make this function called read root and send back a dictionary called hello world. There's two pieces. The key is hello, the value is world. Now we also have another function here, another decorator. This says go to items, item ID, and then it will bring back an item as an integer and a query as a string. Then we say Uvicorn app host 000 port 8080, and that's it. So let's press run. We'll take a look at what comes back. You could probably guess what's going to come back if I just run it. It says hello world, right? Let me send you the link. Okay, so click on the link and you should see a dictionary come up that says hello world. All right, so a bunch of people are typing it in, they're clicking on the link, and they're getting back a hello world. So far, so good? Right? So you're clicking on the link, you get back hello world. All right. Now, what I'd like you to do is try to get to the second endpoint like this. Go into the page that you just clicked on, and this time write /items / a number, question mark, Q equals, and you could write anything you want. I'm going to write pizza. Okay, so I'll copy in, oops, hold on, sorry, having some mouse trouble. So we have items /2 question mark Q equals pizza. Okay, I'm going to take this and I'll put this into the chat. Okay, so you could just click on it and you'll get the same place, but you could change this number to any number you want. So I'm going to write 10. And then for query, instead of writing pizza, I'm going to write something else like chicken. So now you'll notice it comes back. It says item ID is 10. Q for query is chicken. Okay, so what's going on exactly? Let's go back one step. Look what it says over here. It says app-get items and then squiggly brackets item ID. That means you can go to the endpoint for the item ID, which currently does not exist. You could make it up. You could write 1, you could write 10, you could write 10 million, and it will create a virtual page for that item. And then it says when you go to this item, there's two pieces that go into it. One is you have to have an item ID. It's an integer, so you have to put a number. And the other part is you write Q string equals none. So by default, you don't have to include a string. But if you do, it's going to say item ID is your item ID. Q is the query that you put in. So whatever you type in the URL up top is going to come down at the bottom. Does that make sense? Is everybody on the same page? Does anybody not understand what's going on? There's a scary number of people who are pretending to know what's going on. All right, we'll keep on going. All right. So I like to look at a lot of memes because they're very funny. So let's go to this angry baby meme, right? And we're going to write top text, bottom text, and we'll press generate. And we get a picture of this angry baby, right? There you go. There's a meme for you. More homework. Okay, so how did this, what happened with this meme? How did it work? Basically, if you think about it, this is an actual image. In fact, I could right click on it and go to where it says open image in new tab. And I'm going to get this picture. It's an actual image. It's already made. There's a program sitting behind the scenes that says, take this picture, take this text, take the second piece of text, combine them, and output an image, just like when you output something from a function or a file. Now, in this case, if you look really carefully at the top, what does it say? apimeme.com/meme, meme is the endpoint, question mark, meme equals angry baby, and top equals more, and bottom equals homework. Right? So we're passing in those three arguments. What happens if we said more pizza? If I go to that URL, it will create an image and send it back to me. In other words, when that URL is triggered, it runs a function in the background, generating this picture. And that is exactly the same as ours. Look at what it says. /items 10. 10 is an integer that we could put in. Question mark, which is the query, q equals whatever you type in, and it's going to return 10 and chicken. Imagine we wrote a program that says, if you type in chicken, make a picture of a chicken, send it back to me. It would work the same way. So that's basically what we're doing. Now, in this case, we're working on text, but you get the idea of how it works. It works the same way as the meme generator. Sounds good? All right. Now, Jason sent me a spreadsheet, and this is a professor tracker, and it has some people in here. So it has Jason, Sydney, Jenna, Tammy, Adi. You probably know these people. How much coffee do they drink? How much sleep, stress, and pizza? You'll notice that Jason has moderate stress, not very much coffee. He likes to drink tea, but it looks like I'm drinking 10 coffees, but I sleep only 6 out of 100. The numbers are all random, so don't worry about that part. But basically, we have a spreadsheet. We tracked our coffee, sleep, stress, and pizza, right? Now, we're going to take this sheet, and I'm going to export it as a CSV. And then I'll take it, and I'm going to use CSV to JSON. Here's the data on the left-hand side. I'm going to output it as a list of dictionaries. The first one says name Jason, coffee 6, sleep 20, stress 94, pizza 29. Right? So we get everything about Jason in that dictionary as part of a list of dictionaries, and every professor gets their own dictionary inside of the list. Make sense? Right? So, we're exporting all those different pieces from our spreadsheet, and I did it literally from the sheet. I just went File, Export to CSV, I dropped it in here, and I converted it. Okay, so next, let's take a look. It's the same as our program that returns that little dictionary, but instead, look what we're going to do here. Oh, Idris, the site, you just drop in a CSV on the left, and it turns it into JSON on the right. So you'll notice that in the sheet, it just says name one time, name Jason, Sydney, Jenna, Tammy, Adi. But in the JSON version, it says name Jason, name Sydney, name Jenna. In other words, it copies the key and it makes it in a structure like Python, right? A dictionary inside of a list in JSON format. It's a great website. I'm going to send you all the links from today. Okay, so let's take a look at our expanded version. Here we have from FastAPI, import FastAPI, import Unicorn, that we had that before. From data, import professor statistics. Data is this data.py file I have sitting in the same folder, and it has our information, name Jason, coffee 6, sleep 20, stress 94, pizza 29. So I say, when you hit the slash, read the root, and return professor statistics. In other words, return the contents of this file out to the web. And then you could forget about this. We actually don't need this because that doesn't do anything. Let's give this a run. We'll just take a second to install everything. We'll open it in a new window. And then you already have a JSON API that gives out these stats from the sheet exactly like any API you've used up until now. So here's the website. You can click on it if you like, and it will bring back this dictionary. And you already know how to use this. You could use this as a for loop. You could use it inside different kinds of loops. You could do a data analysis on Jason compared to Tammy. You could graph the numbers. You could save them in a different structure, like you could make a list, right? You could find out maximum numbers, minimum numbers, averages, and so on. There's many things you can do with it. I'm not going to go into that because I hope by now you know how to do some things with numbers. Maybe, possibly, potentially. Krishna says, I know that. All right. All right. Now, on line 7, we're referring to the URL address. That's right. Line 7 is if slash, that's the URL, default URL. So there's nothing else there. Like basically just slash, that's the first file, the root directory. If you go to the root directory, which I see people are clicking on the link so that they're going to it, then run the function. Now, we could make something like go to start, and then you would have to go to slash start, or we could do start pizza. In order to activate the function, you have to go to start pizza. But in this case, if you just click on the link, it won't work because it doesn't go anywhere, right? So slash is always the first function that we're going to have, which goes into the main folder. In this case, we only have one function, which is just return professor statistics. In other words, grab this data structure inside of professor statistics, and we import it on line 3. Does that make sense? Okay. And I'll send you all this to check out. Now, I want you to check out something else. This is really cool. Click on the link that I just sent you. So it should look like this on your browser, right? So it's going to show you the results. Now, as you know, I'm sure you've seen this on every site, a lot of times an API has documentation. Documentation tells you what you can click on, etc. The really cool thing that FastAPI does is it creates all the documentation for you automatically. So take a look at this. So type in /docs. So /docs. And it will open up FastAPI website. Again, I'm on the same site, but this one shows you the version of the site and it tells you what you can do. So it tells you that there's no parameters. If you go to slash, it gives you back a string. You saw the string. It's a list of dictionaries. You could press where it says try it out, and you could press execute, and you could try to see what would happen if it runs. And if it runs, what does it do? It says it worked. Jason 6, 20, 94, 29, Sydney 64, 14. And this shows you what would come out. So we know that it works, right? And it says successful response, and we're good. All of this that we're looking at is built automatically. And every single function that you add into your program will be generated as well. If we go back to our previous example with the chicken, and I'm going to go back here and we'll write /docs, it will show you there's two things here. One of them is read the root. The other one is item ID. And if I want to check it, item ID, you'll notice it says two things. I have to put in a number, an integer, but I also could put in a query, a string. I'm going to press try it out. In the item box, I'm going to put in 1001. In the query string, I'm going to write cheese. And then I'll press execute. What's going to happen? It will run that query in JSON, just as if I typed it into the browser, and it will return item ID 1001 Q cheese. You get the idea, right? Yes? No? Basically, automatic documentation. The other one, there's a second version of this. Instead of going to docs, you can go to redoc, and it will open up same kind of idea, just a different version of the documentation with all the links, and you can copy it, expand it, etc. And it's automatic. So that as you code, as you're creating your functions, they're automatically going to get documented. Okay, so there's a lot more we could talk about this, but the really important thing is that we set up the program to return a data structure, right? I'm going to send you more details to look at. There's a lot that goes into this, but if you click on, no, it's not edoc, it's redoc, REDOC. So somebody typed in EDOC, but it's REDOC, redoc. Or you could just type in docs, and that will give you the documentation as well. There you go. Okay, so anybody have any questions, comments, thoughts? Are we on the same page? Okay, so once you have this login, in other words, once you go to this page, you could set up a program in Python to read that API in JSON and do something with it, right? It could have live data, it could have something else. In fact, we could build an API that's a pass-through to a different API. So for example, Jason has a super secret file, but he doesn't want to give people access to it. he could log in using his key in this Python program, share it using his API, and then only some aspects are able to be used. In fact, you've already used an API like this, OpenNotify. OpenNotify uses a NASA API, but basically strips away all the stuff that comes back and only gives you two small endpoints, which are only doing one small query each. But if you look at the NASA API, that's the backend for it, it brings back like 1,000 pages of data. So you use the earthquake API. Imagine if you took the earthquake API, but you only made it have like one earthquake at a time. You could build the one earthquake API to make it work. Okay, so we'll pause for a second. Any questions, comments, thoughts about anything? Line 11 is so that many users, yes. So line 11 is going to create an application, that's this part here, for every time somebody goes to it. So we have a bunch of people logged in simultaneously. Now each person's getting a separate session key automatically. And that way, when you run a query and Jason runs a query and I run a query, we're not seeing each other's results. Unlike in Flask, where it's serving a static web page that's the same for everybody, here it's giving a different query. Jason wants to find out about chicken. I want to find out about pizza. You want to find out about tacos. I don't want to see taco results, right? They have to be separate. So that's why we're running sessions instead of serving up a static page or even a dynamic page. Otherwise, if there's just one login, we'd end up seeing each other's files. Does that make sense? All right. Any other questions? Okay. Idris, what do you say?
Okay, so I'm just thinking about this fast API. You know, in the API, most of the APIs that we assess, like when we're trying to, look at our project, it doesn't allow us access to historical data. I think most of them would usually say that you have to subscribe, you have to make some payment for you to have access to historical data. So with this fast API, does this allow us, for instance, like the example you've shown us, where you were trying to track some historical data about yourself, Jason, and what have you. So with this fast API, and you needed to use this historical data in certain projects, so can we say that this fast API allows you to kind of collaborate and share share it with somebody else, such that you don't need to subscribe to a publicly available API?
Exactly. So for example, let's say you work at a company and people are constantly calling you saying like, how much inventory do you have? How much inventory do you have? You could take a spreadsheet or a database and make an API so they could log in with their program and constantly update their dashboard, update their Power BI, update their Excel. And it will tell them in real time what the number is because they're using your private API.
Yeah. Okay.
Right?
Okay.
Exactly. That's the reason why we're talking about it.
Okay. Thank you.
So if I was doing this lazy, I did it with CSV, but imagine I linked this page, me and Jason shared this page. Jason can come in and put in his numbers. I'll come in and put in my numbers. The page and the website will automatically update. The API will have the latest data. Make sense? All right, so let's look at a few other kinds of APIs, because this is interesting with text. And text, by the way, it does any data structure. So you could do dictionaries, you could do lists, you could do API content, anything that comes out of Python. You've already seen many. All of it you could use inside of your program. All right, so let's move on to something else entirely. Here is a picture of me eating a snack. Look, I'm eating a corned beef sandwich. I'm very happy there. Now, let's take a look. We changed it up slightly, and we say from FastAPI, import FastAPI. We did that already. We imported Unicorn already. Then it says FastAPI.responses. There's many different responses that FastAPI can have. Before, what did we do? It was just like Flask. Before we said, return professor statistics, send out that file, the list of dictionaries for each professor. But instead, what are we doing? We're saying return a file response. In other words, send back a file called snack.jpg, right? So let's give this a run. It'll just take a second to install. And this time it's going to install a few extra packages like Starlet and Pydantic, and that's going to help us display the picture. Let's go over here. Now I'm going to send you this link. Here you go. You can give it a click, and then when you click on it and you see my picture, press refresh, right? And you'll notice at the bottom, it's going to say 200 over and over and over again. And the 200 will basically be, we're serving you the picture, but what happens when you press refresh? What happens when you press refresh? Hello? It loads again. It loads the function again. So it's running line 9 over and over and over again. So line 9 is find this picture, send it out. Find the picture, send it out. You'll notice if you look carefully, it says 200 over and over again. What does 200 mean? Jason asked for the picture. I sent it to him successfully. 200, it worked. But then when you press refresh, it runs the function again. Eventually, you're going to start seeing a code called 300, which basically says, I already gave that picture to Jason. He already has it. His browser doesn't want it again. So use the cache picture instead. But for now, we're going to get 200 over and over and over again as it's sending out the pictures. But nothing happens. It's sending you the same picture. Your browser's loading up the same picture over and over again. Okay, is everybody on the same page? Do you have any questions? Do you understand how it works? We talked about two things: send the data structure out and send the picture out. Okay? Why is it asynchronous? It's asynchronous because the program needs to send out pictures to everybody, but not simultaneously. So basically, what it's doing behind the scenes is opening up multi-threading, and it's processing everybody's request at the same time. Otherwise, it would have to wait for you to get the picture and then the next person and the next person until it's your turn. We could do it like that, like Python normally works, running from top to bottom in sequence. But this way, because we're running it asynchronously, everybody gets served, assuming the computer has enough RAM and hard drive space to serve up 20 pictures simultaneously. But you noticed everybody clicked on the button. We had 20 or 30 clicks. Everybody got a picture. So there was no problem serving it up immediately. Nobody had to wait until everybody else was done. Right? So you could think about it like it opens an asynchronous session for each person to send them the picture. And there's much more detail on pictures that we can go into about bits and having, pre-processing and file size and chunking. The bottom line is that we're basically setting up a session for each person. When you click refresh, it sets up the session. It starts a thread in Python and sends you the image. That's how it works. Okay. Are we on the same page? Okay, so now we're going to talk about, we're just going to take a pause for a second. We're going to pause everything we're talking about. We're going to talk about a brand new concept. I have a file folder full of files, all kinds of different files. And I want to be able to find what files are in the folder in a really simple way without tons of code. There is something that you might learn about in class called OS walk, but in more recent versions of Python, like Python 3.8 and onwards, there's a new feature called glob, which is really amazing and does some really cool stuff. So we're going to take a look at glob now. It's really useful for scraping. And if you're in first semester business, we're going to talk more about it next semester in the API class. So let's take a look at it. So I have a folder full of files. I have 1 text, 2 text, 3 text, invoices, SID, maybe, I have JSON cookies.txt, right? That's a secret cookie recipe. So I have all these different files. They're all text files. In this case, they're all empty. And we want to find out what files do we have. So we're gonna run this program. It says import glob, and then it says files is going to be a list. I just put a little header here called file finder. And I said for every name, which could be whatever variable you want, for each file in glob.glob, anything that ends with .txt. So I said star.txt, and then append it onto the list up here. And then finally print it out as a string and show me what files you found. So I'm going to press run. And it said, okay, I found 1.txt, 2.txt, 3.txt, sid.txt, invoices.txt, JSON cookies, and this is JSON cookies, and this is a list of all of the files that it found. I can make a new file, like I could write sid.json, and if I press run, sid.json is not going to show up because there's a different extension. It will only find files that end in txt. This is really useful because this list gets filled with tons of files when you're doing web scraping or looking through your computer to find files that have a certain pattern or a certain name. This really helps, and it builds a list of where all those files are. Right, we'll talk more about that. You could also use this in fancier ways with recursive searching. So it could look through every folder and every subfolder in your entire computer to try to find files, compare content, etc. Make sense? And I included a link here for you to check out later. We're on the same page? Okay. So I think we're doing pretty okay. Any questions? All right. So Jason, as you know, he likes to complain a lot, and he said, "Professor, this looks fine, but I don't see any eggs happening here. What's the point of this?" I'm like, aha, we'll combine concepts, and we're going to make the world's first egg-based API, just to make Jason happy. So let's go into here for a second. We have a few things. First of all, we have pictures of eggs. Obviously, there's a lot of pictures of eggs in here, many different eggs. Jason's a huge egg fan. Now, we have import random, import glob, which you just looked at, and then we have our 3 files that you saw before for running the egg PI. Yes, it's like an API, but it's an egg PI. Thank you, Adi, for contributing. And we have these 3 lines on the bottom that set up our FastAPI API. We start the app, and then we run glob, and then we basically say, here's the files, look through this folder, and anything that ends with JPEG, which I think is the file name for all of them, for some of them, append to JPEGs. Wow, you guys are on fire today. So I'm going to grab this for a second, and I'm just going to copy it, and I'm going to change this to JPG as well. All right, now I don't need to print any names out, and I don't have to print files, which shows me all the files, but basically what's going to happen is it's going to take this list, it's going to look through all of these pictures here on the side, and anything that ends with JPG or JPEG will get added to the list, right? This list up here, files. Then, this is the main part of our program, we have global files, so it's going to import files from the outside of the function. File equals random choice of files, and then file response file, return a file. So every time you click now, you should get a random picture of eggs. Let's press run. We'll give it a look. Here you go. And I hope you enjoy clicking on JPEGs. There you go. Okay, so here's a picture of eggs. I click on it. Another picture of eggs. Extremely interesting. There you go. So the more you click, the more eggs you get. And it's fortunate for you that I happen to have like 2,500 pictures of eggs on my computer. The perfect thing to use in our program. Jason is extremely happy that you're clicking on JPEGs. I don't even know how to say it anymore. Okay, so basically, again, we're importing the list of files. So that only runs one time when the program turns on. Then we're doing random choice files. So it's going to grab a file inside of there and store it inside a file, and then it's going to send it back to you. And then you see the same thing happening here where we run through all the files. This only happens one time. We run through all the files. We look for anything that ends with JPEG or JPG, and then we bring it back, right? This could be simplified also with for file extension in list, then run this code, right? But you get the idea. It's going to take all the photos here and put them through. And every time you press refresh, you should get a new picture of eggs, which I ate for this example. So congratulations. I knew that eating eggs would one day come in handy. Everybody's on the same page? I see some people are refreshing. They're checking out the eggs. Eggs are looking good. Great. All right. So let's just recap. What do? We put together a list of pictures. We then use glob to identify what the names of the pictures are. right? So we got a list of all the pictures, and then we stored that inside of files. Then we said, pick a random one from files, save it inside of file, and then just print that. So every time you press refresh, it will grab a random one and put it out on the screen. And Jason says, okay, but how about we combine the ideas of Flask with our API? In other words, we generate HTML with our API. It's a little more complicated. Let's look at an example. All right, so here we have the same thing we did before. The part of the code that repeats is the only part that repeats is line 22 to 26. In other words, if the API is running like it's running right now, and I drop in a new picture, it won't get captured by this code because it only runs once. If you wanted to have like an upload and download API, you'd have to take this content and put it inside the function. So it runs every time somebody refreshes. But it uses up way more memory if you do that, right? So the only thing that runs is these 3 lines. Import the list of files, grab a random one, display it. But then it's going to be a different random one because those are the 3 lines that run the next time as well. Make sense? All right. So let's take a look at this one. There's a few more lines of code, so don't get worried about that. We have import random, import glob, import OS, import FastAPI, import unicorn, import responses, time, etc. Now here we have static files and templating. This lets us set up 2 folders, just like we had in the example from Vin that I showed you earlier. I don't know if we still have it open, but that example that had the website on it, right? It lets us create the same exact idea. Static files go into here. There's a million JPEG pictures in here. And then the templates hold index.html. That's our index file, right? Now, there's a little bit of setup here. So we have to say app equals FastAPI, app mount static. Basically, we're telling it static files directory is static. All the pictures you want are inside of here. You'll notice in our last project, there was no folder. We just dumped them on the outside. This time, we have to put them on the inside somewhere. Then I set up where the template's located. Templates are located in the directory called templates. Index.html is inside. Again, just telling it where to find the folder. Then I did timestamp equals datetime.datetime.now.timezone.pytz.timezone.us Eastern. So we get back, ultimately, in timestamp, the time right now in Eastern time. It took a bunch of working to do that. It is not easy to work with date time, as I'm sure you know. Then I built my program again. It says files. I grabbed the same code. So I did everything that ends in JPEG, everything that ends in JPEG, capitalized, grab it, add it into files. I printed it out. I was just testing it. I don't have to print that. And I don't have to print this either. Okay, so I'm just appending. And this is our main function. This is the main part of the program. It says / response class is HTML response. What does this mean? We looked at sending back a string, a text, JSON. We also looked at sending back pictures. But this time, what we're sending back is HTML. The HTML is going to render, and inside of the HTML, it's going to use Jinja to pull out items and plug them into the HTML. So that's not being done by FastAPI. That's being done on the website by Jinja. Now we have async def main, request equals request. So basically, when you click on it, run the request. Global files imports it. We're going to pick a random one in file. But just like in Flask, we're going to say return templates.template response, load index.html, and send back 3 pieces. The request, which in our case, there's no request, it's just /. The file, which is a random picture, and time is a random timestamp. Now, on the index.html side, I added a few extra things, but basically what it does is I wrote the title, Nature Image API. I linked it to a CSS style sheet, which is in the static folder. I said the time on the server is now time EST, so it'll show you the current time. Enjoy your image of Northern Ontario. And then it put out file. File was the picture that came before, and I limited it to 750, and I just made a little voting box so you can click on it if you like the picture. I didn't connect the voting to anywhere, so it doesn't actually save it. Let's run this for a second, and we'll open it in a new page. Here you go. You can enjoy pictures of Northern Ontario. I took them around Sudbury area. And every time, so we have the little buttons here. You can click on it. I could have made it that when you click on it, it reloads the page. That would have been smart. But basically, it shows you a picture. If I press refresh, it will show me the latest time and date. with another picture. This is at the university. This is at Onaping Falls. This is at Onaping Falls in the winter. This is the university. This is the smokestack. This is actually at the Big Nickel. And there you go. So every time you click it, you'll get a new image from Northern Ontario. I had like 1,000 pictures. I think there's even some pictures of Adi inside of here. And if you just refresh it, you'll eventually see all the pictures that are in the folder. There are many, right? So the idea is that it's serving up the images. Now, you'll notice that some API, so if you go to like placekitten.com, it says go to this website, and we go to placekitten.com 200/300. It's basically looking for those two numbers. So if we did 2000 by 300, we'd get a super wide image that's only 300 high. If we did it the other way, so we did 200 by 3000, we get a very tall and skinny picture of a cat. If we made them approximately the same, so this is 200 by 300, we get a picture. So what's it doing? Again, it's sending out a picture. It's running a function to crop an image and then returning it based on the sizes that you put in, based on those parameters. You could think about it like plugging those elements into an F string and then using an image package in Python like pill to process it, the Python image library, to process it and send it back. So for example, you could have an image that you drop it in, you press a button, and something happens, right? Sometimes some APIs, you want to return text. Some APIs, you want to return images. So for example, placekitten doesn't return text, it only returns images. Some APIs will send you back JSON text, but inside of it, it'll have a link to an image. So you could use that in different ways. It gives you more flexibility, right? So you're able to use the link, save the link, download the image, or use a different part of what's coming back. So there are a lot of different options in terms of how you want to use it. Well, I just talked for 50 minutes straight. Does anybody have any questions, comments, or thoughts? More pictures of Northern Ontario? Okay, now a cool thing is, I want to show you something interesting. Well, that's what this does. This is returning image and text. You can see it here. This part is text. It's coming from the HTML file. This is plugged in from the Python file, from the FastAPI, and this is coming from FastAPI, the image. And they all come together by plugging in time using Jinja and plugging in file using file. And they're coming here. Oh, so this is the same as the meme. Let's go back to the meme for a second. How does the meme work? So basically, we'll open it in a new window. How does the meme work? If you just take meme angry baby and you get rid of the rest, it's just going to say top text, bottom text by default. There's a program in Python that you could pass in these words, right? Pass in those queries, and then it will run the program, insert the words, generate a new picture, and send it back. So it's basically just looking at the Python image library and saying, modify this thing. How could we use this in our case? Every time that we serve a picture, instead of returning a picture, we could have it watermark the picture first, right? Let's take a look and see if that's really quick. That looks complicated. Let's look for a simple one. All right, let's try this. I don't know if it's going to work. So we have this code here, right? And maybe we'll go to the egg one. Okay. So we'll put it in here, right? So here we're going to make the watermark program. And we know that what we have to watermark is the file. Okay, so let's grab some libraries. And I'll just put these. I want to keep this one the same. Let me Let me duplicate it and then work it. Oops, sorry. Okay, so this is the original. I'll get rid of these changes. And then this is the changed one. Okay, so let's go up to the top and we're going to add in the 3 libraries that we need. Python image library, matplotlib, and NumPy. Okay, so we're going to focus over here. We got the image already. Do we want to do a text watermark or an image watermark? Yeah, we could actually okay. Let's see for a second. Okay, so we open the image. Let's try this. Okay, so we have size, it's a tuple, 500 by 100. It says image.copy, undefined name image, but I thought we imported it. Okay, hold on. So we're going to open that. We're going to open the file in image. Then we'll have image size. Image.image open. Size is 500 by 100. Crop image is image.copy. Crop image thumbnail size. Okay. And then we're going to say copied image paste. File equals this. I don't know if this is going to work. Let's try it. So we'll give it a run. And this is going to take a second. Did it crash? I think it's trying to open the wrong thing. So we have open up the image file, size, I think it's processing it in here, but I'm not 100% sure. Let's try this. Return copied image. I think they might be interfering with each other. Because I'm not getting the other window now. Okay, well, let's check first of all if this is a problem. I'm just going to say return file. And then we'll comment this out and this. And, we're not getting the window at all now because it's trying to run this other window. Okay. Yeah, I think this completely overwrote the files that are in here, and it stopped it from working. I think the easiest thing would be just to replace the library. Let's see if there's another. Okay, that part's okay. File equals random choice from files. File response files. Should work. But for some reason we're getting this. Yeah, we have to look at it and say, like, why is it opening this window? It shouldn't open this window at all. And it looks like this is also causing FastAPI to crash. So where we process the file, like which one we take out and how that works, we could do it in a bunch of different places. Like we could do it up here. Instead of doing the random choice down here, we could do it inside. But basically the end results would be the same as the meme. I have to like take it apart to figure out which part exactly is crashing. But it's telling me that Unicorn is running, but now because I ran this window, I can't see it. So we'd have to go through all the packages and say, like, okay, what is messing with it and why is it showing up? But that's why it's good. It's a Friday meeting. We could figure it out. So FastAPI works. Pydantic is okay. There should be, maybe it's at the bottom. There should be something in here that's preventing it. Worst case scenario, we could just copy this data and then try to run this elsewhere in the pipeline. So sorry, it's not perfect, but it's doable, I'm sure. So any questions, comments, thoughts? Covered a lot of different things. I'll show you one last thing. Let me just grab an image. Hold on. All right, so I showed you this before, but you should get an idea of how it works now. Here's this website, Tune Me, and it basically works the same way as everything we've been talking about. I'm going to press upload. I'm going to drop in a picture, and it will think about it for a second. So you can think about it like the first step is the upload element that we send in the picture to the pipeline. It then gets read by a computerized system like OpenCV2 or something like that, where it looks at the image and manipulates it in Python, and then it's going to return a cartoon. But basically just using that pipeline of like transforming it and then outputting the results. So there you go. I've always wondered what I look like as a Simpsons character. So you get the idea. That one looks the most like me, interestingly. And that's it. That's everything we want to talk about. So I think it's really a good idea to look into FastAPI. I'm going to send everything that you saw today and all the links and all the pages for everything. I'm going to email it to you in a second. I highly recommend check it out because it's a great way to share information back to your clients or your customers as you're creating data. This is a good way to share it directly out of Python and build your own API so other people could build software or dashboards to interface with your data, especially if it's live or you're updating it all the time. Any other questions, comments, thoughts? Have an amazing weekend. Nice to see you. and school's almost over. We got like just a few weeks left. So make sure that you plan out the rest of your semester, that you know when your homework assignments are due. Talk to your professors to make sure you know the deadlines of when things are supposed to be handed in. Thank you. We did cover a lot of topics, but I hope that it was useful and you'll use it in the future. And like Jason says, it's the only egg-based API in the entire world, and you were here for it. Congratulations. It was excellent. It was AP eggs. What was it? API? AP. Thank you for your time. Bye. I hope you get cracking.
Thank you.
Bye, everybody. Have a good week.